projector, but I found more effective projecting from the glass nodes than using that projector. Of course, the worst case, the worst story I have ever done with a projector is many years ago, so maybe everybody has forgotten it by now. I think I was lecturing in Wildhall, and there was no projector in the room, so I went to the central office of the IC department that is in that building and borrowed their projector. Unfortunately, I toppled it and shattered it. I returned it in pieces. Obviously, I never asked for anything from it again. So let's go to the class notes. Go to files. And go to class notes. And down here you see more controller PDF. That's the one we're going. So, this is from the manual of the controller, which I should really scan also the cover, what it looks like. Anyway, it's a little box about this wide, this tall, and this long, okay? And it has screws for connecting wires. And you see here the signals that are external to the box where you can connect wires. So let's understand first of all the notation. Process is the industry term for measured output. It's the signal I'm connecting to the controller. So that process P that you see here is our wire. Okay? So that P is the wire, and actually because in the Laplace domain what we're going to be saying is going to be Y prime. Set point is the set point. Now the set point can be done manually. You have basically bars that you can adjust up or down, or you can enter values. But also, you could have this controller taking the set point as an electronic signal typical from another controller. Cascade control, I don't have time to cover it, but it's a very common type of control. In cascade control, you have a second feedback control loop embedded inside another control loop, where the set point of the embedded one, which is called the slave controller, and the other one is called the master controller, the set point of the slave controller is the manipulated input, it's the output of the manipulated input for the master controller. Okay, so the master controller outputs the set point for the slave controller. And a common situation, let me try to give you a common situation for cascade control. I think,
Kind of like
yeah,
a
okay.
name for it.
Huh?
Even master, that's really the name of it.
Yes.
It seems
Slave loop and master loop, yes.
just names.
Well, that's well, because the master gives the set point to the slave.
That's just a computer.
So the master tells the slave loop what it wants to do.
Yeah.
But if we talk about, for example, level control, what you want is a particular level. The master controller will take the level measurement and it will want a particular flow rate to achieve that level. It gives set point what flow rate I want to a slave controller, and the slave controller will actually be measuring flow rate. The master measures level. The slave measures flow rate and adjusts the control valve up or down to achieve the desired flow rate. You understand? So master controller takes his measurement. Master and slave controllers take different measurements. The master takes as measurement the level. The slave takes as measurement the flow rate. What you're really manipulating is the control valve that changes the flow rate. Okay, so the real manipulated input is the air pressure that goes to the control valve. Okay, or the signal that goes to the electropneumatic air to, sorry, current to air converter. Okay, so the master has as output the set point of the slave, and the slave has an output the current that goes to the air to the current to air converter that opens or closes the control valve and therefore changes the flow. So that's a very common situation. So in such a situation, the master controller for the level, the operator will change it. But the slave controller needs to get an electronic signal. That's why that's why S, the set point, can be coming from the wire. So that will be wiring from the master controller to the slave controller. Clear, everyone? Feedback is something very interesting. We're going to really understand feedback. Adaptive gain, you can have some modification to KC instead of being constant. But that's not standard PID, and track command is not standard PID. And you see two outputs. The output is the output of the controller, the U prime. And this is the absolute value of the result output. So this is the hardware. So you will have wiring connected to those and wiring connected to those. And you can do different types of control laws. You can see PID, which has PI as a special case, and P as a special case. For those that will see P is really implemented differently. And PID adaptive gain, you see that. And you can do PD and ID, but nobody would ever do those. Since it can do it, it gives you that option. And now we go to, you see here the parameters, and you can see here H or S. H is hardware. So these are the hardware connections. So here you see that, okay, what type? But here are the hardware inputs, P process, that's the Y prime, S the set point, F that we're going to really understand, and forget the other things. But here are our main connections. And software are the S's, and SPG, proportional gain, that's our KC. Time integral, that's our tau I. Time derivative, that's our tau D. Derivative gain, as we will see, this is related to that alpha. That has to do with our filter. So filtering is embedded into that derivative gain. Very important, the first two ones. There's a diagram that shows you exactly what this control is doing. We're going to follow this diagram after the break, but let me just say a little bit about this. So I'm showing you, this basically shows the basic things. So you can see, here's your P, your Y prime bar, going in. Here's your S, your set point, going in, either coming from a wiring connection or adjusted according to the operator turning a knob. The output is your U prime bar. That F is the one I'm going to explain after the break, how you can get true proportional action. And here you have also output the actual value of the error for plotting purposes. And as I said, I'm not discussing. Let's see. Okay, but if you look at this picture, you have a choice here. This is the summing junction. You can either make it this side plus and this side minus, or this side plus and this side minus. It's really how you define error. The convention in all the books you see error defined as set point minus measure. But if for some reason you wanted to define it the other way around, you could have chosen this. So it's how you define it. And by the way, how you define error, we switch the sign of KC, of course. So anyway, we should choose the standard textbook notation. And the other one is the one that will eliminate partial credit if you mess up. So you can see there are two plus minuses here. Reverse direct and this one. Both are reverse direct is how you define the error, and this is the plus minus sign, is your sign of KC. Okay? So be very, very careful not to mess up that sign. Clear, everyone? Now, the one we have in the Unitops lab, I think you directly enter the sign. We don't have this Mickey Mouse business here. Okay. All right, so let's take a break. And after the break, we'll follow this diagram and see exactly what this controller implements.